Welcome back to Pass the Torque. I'm your host, Katie Cadre. This week we have Charlie Bacon with us to tell you about Cooperative Service Aids. Don't forget you can leave a question for Charlie in the comments below for a chance to have them answered later this week. Let's go ahead and jump in with question 1. Can you explain what you do now and talk about your career at NASA?
Sure. Well, right now I work on a couple of different things. I'm supporting the Exploration and In-Space Services Division as we try to reach out and expand servicing in the industry. We try to develop more capabilities and communicate about what those capabilities are, what kind of things are needed in order to make servicing more of a part of what gets done in the industry. So not only servicing, but assembly and manufacturing as well, as we've started to bring those into the mix over the last few years, looking at how assembly and manufacturing can be a part of servicing and create that OSAM initiative. The other thing that I do is I work on a project here at Goddard called CCRS, and that stands for Capture and Contain Return System, and that is a project that we are working at Goddard that is part of the larger Mars sample return campaign. And so there is a campaign that NASA is working on right now that is looking to eventually bring back some samples of dirt from the surface of Mars. And so there's a lot of different projects. There's multiple launches involved. Actually, it's getting started with the Perseverance rover that's getting ready to launch later this summer. And so that is going to be the first step towards eventually bringing those Martian samples back to Earth. And we are working on a project here at Goddard, again called CCRS, and that is going to be responsible for actually capturing the orbital sample in a capsule or in Mars orbit and bringing it back to Earth and eventually re-entering the Earth's atmosphere. So that's a really neat and interesting project.
What is a cooperative service aid and why is it important?
So a cooperative service aid is something that you kind of install onto a spacecraft or a part of a spacecraft or an observatory that just helps facilitate and enable servicing. So, it kind of gets taken for granted a lot of times, but if you're doing something as a human and you're interacting with something, it's designed for you to interact with, right? But a lot of things in space are not, because most things in space never are there's no human or robotic interaction with those things once they go up into space. So some exceptions to that are like the International Space Station, which obviously has humans living on it. The astronauts do EVAs and go outside and work on things. There's multiple robot systems that exist on the outside of the space station that perform some tasks as well. So a lot of those features on the space station are designed for human and robotic interaction, and so they feature things like handrails for the astronauts or grapple fixtures for the robots, or there's docking adapters for the vehicles that come up. Those kinds of things are all examples of cooperative service aids, and they enable those operations to take place. You contrast that with a satellite that launches and nobody ever sees again. There's no cooperative features on that to enable servicing. So the idea is to put cooperative features that are used on things like the space station or the Hubble Space Telescope onto satellites so that they can also be serviced. I think almost anything can be cooperative if you envision it, and there is a large, we talk about a spectrum when we talk about servicing, so that we can create a spectrum of simple things that can be done that can be considered cooperative, and then there's more complicated things that can enable even more operation. So it's kind of how much do you want to do with it. But non-cooperative things are things that are really trying to almost in a way prevent any access or any servicing. So a really good example that we've been working with for a long time is refueling valves. Refueling valves on satellites now include a lot of caps and wires and blankets over them, and really because, again, there was no intention of anybody ever accessing those valves once the satellites launched. But now we are looking at how can we put something in that is not so uncooperative, something that's more friendly to robots interacting with it and being able to perform the servicing operations like refueling. So a good example is the Cooperative Service Valve, or CSV, that we designed within NExIS over the last 5 years or so. We've been working on developing and building up, and that was where we looked at, well, this is a refueling valve that exists on a satellite today. We know that trying to refuel that valve on orbit is very hard because of the caps and the wires involved that are usually installed. So how can we make that job easier? Well, we can get rid of those caps, we can get rid of those wires, we can put a more cooperative interface onto the front of it so that a robot with a refueling tool on the end can more easily align and mate with the valve.
Why do you think most satellites weren't designed with servicing in mind? Why do you think that mentality is only changing now?
Well, I mean, I think for a long time the technology wasn't available to allow servicing on a scale that would be required for satellites to include those types of features. It's obviously very difficult to perform these types of operations with humans. The Hubble Space Telescope and the servicing missions that astronauts were able to do on that was a really good example, but trying to do that for use human missions for all the satellites that are in orbit simply isn't feasible. So what you need robots, and in order to do that on a larger scale. And it's only been within the last maybe 20 years that the robot technology has really come along in such a way that maybe you could start to envision how it could be used to perform servicing missions. And that's exactly what's being done with OSAM-1 right now, is to show how the technology exists to perform those kinds of operations.
Can you give us some examples of cooperative service aids that have been used in the past and are active in space today?
Sure. So I talked a little bit earlier about the best examples of being on the ISS and the Hubble Space Telescope. So yeah, things like handrails for astronauts. That is a perfect example of a cooperative service aid. That was put there to help the astronaut service the telescope or to work outside the space station. And for similar fashion for robots, you have grapple or grasp fixtures, things that allow the robot to easily pick up and manipulate an object. There are other examples like blind mate connectors. So if those were used as well. So when you have maybe a box that a robot might try to replace, it's difficult for a robot to interface with a small electrical connector. But if you can place a connector on the box in such a way that it basically mates and demates as the robot picks up and installs a box. That's kind of what we call a blind mate connector, because it usually happens on the side that the robot opposite from where the robot is holding it. And you can't see it, but if you use some mechanical fixtures to align the box in such a way, and you design the connector in such a way, you can now use those connectors on the boxes. And so those were used on the instruments and modules that were put onto space station. That some of them that get changed out by the robot, and also on the Hubble Space Telescope. And I also mentioned the docking adapters earlier as well. So that's another example of you have these visiting vehicles coming from multiple places, right? There are American contractors who launch up to and dock with space station, and then there's international partners as well that do the same thing. They all have to kind of dock with the same interface. So there's a common adapter that was designed that multiple people could interface with, and so that was another example of a cooperative interface being installed that allowed multiple uses and reuse and utilization by different organizations.
How do you approach servicing a non-cooperatively designed spacecraft versus a cooperatively designed spacecraft?
Well, you definitely you kind of approach it in the same way. You have a mission that you're trying to execute, and so you work your operations and you come at it depending on what the interface is or what the satellite is that you're trying to service. But what one of the things that can really make a difference is what you bring with you to perform that job, right? So it's a lot easier if you have a satellite that was designed to be serviced. It's a lot easier to do that. You have to bring less tools. Is a really good example of something where your job becomes a lot easier because there's just not as many things that you have to do to service that satellite. So I'll go back to the refueling example. Imagine that you go to fill your car up at the gas station. Well, your car has a refueling port already built into it, and so and you have a gas nozzle at the station that is designed to interface with that port. So it's a fairly simple process to open up the gas port, put the nozzle in and connect the pump and refuel your car. Well, now imagine that you had a car that didn't have that refueling port. Well, now I have to bring all kinds of tools. If I'm still dedicated to refueling that car, I have to bring all kinds of tools with me, to maybe a saw or a drill or something else to cut open my car and get to that refueling tank and be able to fill it with fuel. So I took something that was all I did was take away one simple interface, but now I've made my job a lot more complex, and I've really increased the number of things that I need to do that job.
What are some planned uses for cooperative service aids? How do they fit into NASA's plans, and what will they look like in the future?
Yeah, so I think one of the things that we're seeing right now is because of the work that has been put into making satellites refuelable. Now NASA is starting to require in some of their projects that these things are refuelable. So we're starting to see that with projects that are in development now. There's requirements for these things to be refuelable on orbit. And there's also other things being explored as well. I mentioned boxes or modules that could be changed out on orbit by a robot. So we're starting to see some requirements for projects in development for that kind of capability as well. That is not as much of a one-for-one replacement as like replacing a fill and drain valve is, but it's still something that can be pretty easily done if it's put in the early stages. So as we've developed this technology and we've identified these operations that can make these things possible, it can be hard because spacecraft programs are in development for many years, and so trying to catch things on the later end of development is hard. But now with some of the things that were early in development, we're able to identify ways that they can incorporate these servicing features. And so I think 5 years from now, when some of these spacecraft that are just starting in development now actually, or 5 years and longer, when they actually start to go up into space, then they will be utilizing those features. And so that'll be something that takes a little more time to be able to see, but is definitely part of the plan.
What is your involvement with the Mars Sample Return mission? What part will Cooperative Service Aids play in that?
So I am a manager for the Capture and Containment Module, CCM, which is one of 2 modules being built as part of the CCRS project. And the CCRS project is the part of the Mars Sample Return campaign that is being developed at Goddard. And so that module, the CCM, is going to be responsible for actually catching the orbital sample in Mars orbit and packaging it up for return to Earth. So that is going to utilize some cooperative service aids. There's a robot arm built within the CCM that actually manipulates the orbital sample once it gets inside, and that has to it has to pick up a couple of different things, and so those things are going to utilize cooperative fixtures that make it really easy for that robot to grab onto those components. One of the challenges that we're going to have on that mission is that it's going to be taking place in Mars orbit. And so, unlike OSAM-1, which is going to be operated in low Earth orbit, there's a really long latency when we're sending commands to that payload. So we're not going to be able to take advantage of low latency teleoperations as OSAM-1 is going to be able to do. So when we send a command for a robot to pick something up, we're really going to have to make sure that the physical interface and what the robot is going after and the way that the robot performs that operation works really well, and we have a high confidence that it's going to work the first time. And so that means that those cooperative interfaces between the robot and the thing that it has to pick up and manipulate, is a highly reliable, easy interface and operation. As in a similar way, the orbital sample capsule that is actually going to be in Mars orbit when we capture it, right now the team is looking at putting cooperative fiducials on the outside of that capsule to make it easier for the sensors to see and make it easier for us to eventually rendezvous and capture with it. So those are both examples of cooperative service aids that'll get utilized on that mission. So a fiducial is like just something that a camera system can actually see and be able to distinguish and pick up. So what you usually try to do is design them in such a way that they're very different from from anything else that you might see. So a lot of satellites are covered with blankets, and of course, if there's no distinguishing features on a large blanket area. You're looking at something that kind of looks like tinfoil, and it's hard for a vision system looking at that to identify what the feature is. And of course, you want to be able to provide distinguishable features so that the robot system and that vision system and that machine vision that's utilizing and kind of driving the robot or driving the spacecraft to a certain point actually knows where it's going and knows what it's looking at. So the fiducial is just something that the computer vision can actually, or their machine vision can actually pick up. So usually it can be a lot of different things. It can be a small decal with a bunch of random squares on it. It can be something that's 3D. So they use these on space station right now, where there are like small machined targets that actually utilize both contrasting colors, black and white, as well as like three-dimensional features. The target itself is three-dimensional, and so they're able to design that in such a way so that when the camera is looking at it, the operators on the ground can utilize how that target looks in the image coming down to them, to give them a sense of how far away they are, and if they might be misaligned, or if they're where they want to be, which is usually co-aligned and centered on their target. Right now, the plan is for RST to include a grapple fixture, and that grapple fixture will have a fiducial on it, located in such a way very similar to what was done on HST and ISS. So that fiducial will be located in such a way to allow the operators or potentially a closed loop system controlling the robot to align to the fixture and get it in a position for grapple.
What do you like to do for fun outside of NASA?
So I have because we've, especially over the last 6 months or so, been spending so much time at home, I've really gotten into my woodworking. So this was something that I did a little bit before, but I've really taken up over the last 6 months or so, as I've had more time to practice and kind of build up my workshop here at home. So that's something that's been keeping me busy, and I've really been enjoying doing, learning how to do different things, and make different pieces of furniture, or how to find ways where if there's something that we need around the house, I can actually go and build it, and we don't have to go to the store and buy something. That's been really fulfilling and fun for me to learn how to do.
Thanks so much, Charlie. And thank you for tuning in to another episode of Pass the Torque. Don't forget to stick around for Charlie's show and tell, or drop a question in the comments below for a chance to have it answered later this week. We'll see you back here next week for another brand new episode.
So this, let me see if I get a good camera on it. So this is like a, like a coat hook rack type of thing that you might put next to your entry door. My mom actually asked me for one of these. She wanted something that was small enough for her specific space, and had some hooks and also a shelf so that she could put a few things on. So I built this. Another thing I've been working on is cutting boards. So this is the first cutting board that I built, and kind of just a prototype to give me practice building it, but it's still useful, and we've been using it in our kitchen, and that's been good. And then this is just kind of a very simple box that I built, and I wanted to try making things with these joints. These are called box or finger joints, and so making things with that. And so I built this box and gave it to my wife, and she's been using it to organize some of her hair ties and other things on her dresser. So this is just another kind of practice thing that I did, but I'm gonna be able to learn from this and build up more things like it, I'm hoping soon.